In this question, we're told that provided below is data on the percentage of people with a college degree or higher and the percentage of low-wage workers for 12 U.S. states. We're going to use Desmos to first calculate the correlation coefficient for these paired data sets. We can paste that first data set into our x1 variable and the second data set into our y1 variable. And there are a few different places we can get it, but we're eventually going to get into testing a correlation. So we can go ahead and use this drop-down menu and get that correlation coefficient value for R is negative 0.8436 once we round. Then in part B, we're asked to construct the appropriate hypotheses needed to test the claim that a negative association exists. Our null hypothesis would be that the population correlation coefficient is equal to 0, and the alternative would be less than 0. In part C, then, we want to test the hypotheses with a significance level of 0.05 and complete the test. We know that our alternative statement in this case is less than, and we've already opened up this drop-down for testing a correlation. We can see 3 different p-values given in this case for rho, with less than, greater than, and not equal to written in subscript. What we want is that p-value for rho less than 0, which would be 0.0003 once we round to 4 decimal places. In this case, our p-value is less than or equal to 0.05, which is our given significance level. So we reject the null hypothesis. In this case, there is sufficient evidence to discredit the null hypothesis. So we conclude that rho is whatever our alternative statement tells us. In this case, less than 0. The claim is supported as the 2 data sets share a significant association. In this case, we want to say share a significant negative association. Obviously, some of our answers will change depending on the p-value that we have, the alternative hypotheses that we have, but this general process will stay the same. And under this testing a correlation tool, we can find that value for R, as well as the corresponding p-values for each of those 3 different tests we might conduct.